Hey, Trig class, let's look at 7.3 notes, computing the trig functions of acute angles. So we want to find the big ones, the special angles as we call them in this course, pi over 4, 45 degrees, and then pi over 6, pi over 3, 30 and 60 degrees. We want to find those exact values. So we're going to start off with pi over 4 or 45 degree measures. Okay, so if we have a 45 degree angle in a right triangle, well, by the 180 rule for triangles, all angles in a triangle add to 180. Well, I know that this has to be 45 also. And that means that A is equal to B. They have the same length. So I have A squared plus B squared equals C squared, but it's also A squared plus A squared equals C squared, or 2A squared. So there's this relationship that I can get, the easy relationship that I can get from the 45, 90 triangle. Now, if we start off with, we just make A and B just be one unit length, then we end up with A squared plus B squared equals 1 plus 1 equals 2. So C squared is 2, that means C is the square root of 2. And if C is the square root of 2, and A is 1 and B is 1, I know all three sides. And so I can come up with the sine and the cosine and the tangent, all that good stuff. So sine of pi over 4 or 45 degrees is opposite over hypotenuse, which is 1 over the square root of 2. That simplifies to square root of 2 over 2. Cosine would be the same thing because it's adjacent. Well, they're both, the numerators are going to be the same. And so we get the same thing. Tangents, sine over cosine, they're the same, so dividing anything by itself, you get 1. And so there are the special angles for sine, cosine, and tangent of pi over 4 or 45 degrees. All right, flipping those over, flipping over 1, you're going to get 1. Flipping over 1 over the square root of 2, you get the square root of 2. So secant of pi over 4, cosecant of pi over 4, or 45 degrees is the square root of 2. All right, so what do I get when I plug these in? Again, just go through each one. That's square root of 2. That's 1. Square root of 2 times 1 is, that's square root of 2 over 2. That's 1. So we get square root of 2 over 2. All right, cosecant is the square root of 2. Tangent of pi over 4 is 1. So square root of 2 times 1 is square root of 2. Again, we don't need a calculator for the special angles once we put these specific values to memory. Again, you're going to need to memorize a lot of this or be able to derive it. You can derive it again, but for time's sake, you're going to want to put a lot of this to memory. Right. Alternatively, I just want you to understand, you're not going to be able to, like when you see the square root of 2 over 2, if you type that into the TI calculator, it's going to give you a decimal. Okay. When I type in, I just want you to see if I type in cosine. And by the way, here's your mode. You can see if you're in radians or degree mode, you're going to have to be able to adjust that when you do these different problems. I'm in radian mode now, so if I did cosine of pi over 4, that decimal matches with that decimal. All right. If you're ever, if you're confused, just type them out there. The numbers that we're going to see are the square root of 2 over 2, square root of 3 over 2, 1/2. Those are the primary ones. So you don't have to put them to memory. You just have to remember to check those, the things to check. So again, square root of 3 over 2. There's another decimal that you're going to recognize before the end of this course. All right, the 30 and 60 degree values, we actually get those from a equilateral triangle. Is where the first derivation of these side lengths come up. But you could read through these slides and see that if we basically mirror image a 30, 60, 90 triangle beside itself, we get an equilateral triangle. And then we know these sides are the same. This is, the base, the height. We can come up with what the side lengths need to be. And anyway, as you do that, you read through that, you'll see this relationship that we know that if this is 2, right, and this is 60 degrees, This is 6 degrees, and this is 2. Well, these are 30 and 30. So these, A adds up to 2. Or A plus A has to add to 2 because they have to be the same size if all the angles are 60. So A plus A is 2. So A is equal to 1. And so again, now I know 2 of the 3 sides. I can find the third. Do the math. That's the square root of 3. Now I know all 3 sides. So I can do the opposite adjacent hypotenuse and find all 6 trig functions. So there they are for the 30s and the 60s. All right, it's the square root of 3 over 2 this time instead of the square root of 2 over 2, or possibly the square root of 3 over 3, depending on if we're doing sine, cosine, or tangent, cotangent. All right, secant, cosecant, just flipping over those cosines and sines from that previous slide. All right, find the exact value again. There's cotangent pi over 6. If I don't know that, first of all, I can't, there's not a cotangent button on here, but I can get cotangent from tangent. So I'm going to do 1 divided by the tangent of pi over 6. So pi again is second caret pi over 6. So there again, there's 1 divided by tangent. That's cotangent of pi over 6. I get that. Maybe don't recognize that decimal, but if you square it, let me just show you this. You can just press square, and it'll square the A and S means the previous answer. So if I square that number, I get 3. So what does it mean? It means that number was the square root of 3. So that's a way that we could do it. But again, you can always, just remember, you do have access to your TI calculator on the test, on the midterm and the final. You can always do things like, what's the square root of 3? And there it is. What's the square root of 3 over 3? There it is. Now, there are these decimals, and I can like jot them down. And then if they show up on the test, if I do tangent of pi over 3, I hit enter, and I see that number. I was like, oh, that's the square root of 3. So I know that's the answer, So those are little things that you can do to have technology help you and remind you. So you not have to memorize so much. But you're going to have to memorize a lot on this test, but the final exam especially. But the technology will minimize what you have to memorize. All right, again, there is the 3, there are, I guess I should say, the 3 special angles that are acute in radians and degrees. So 30, 45, 60. And then there are all the different values of the 6 trig functions for those 3 special angles. And if you are paying really close attention, you'll see the same numbers just show up in different places, like a half, square root of 3 over 2, 2 over 2, under the sines and the cosines. And then likewise for tangent, 1, square root of 3 over 3, square root of 3. And then we flip those around and we get the same ones for cotangent. We flip these for sines and cosines, and we get the reciprocals of these are the values for secant and cosecant. Again, use your TI calculator and see what all these different values look like. And that would be something worth your while to kind of acquaint yourself with those decimals. All right, and then we can do all kinds of different math type problems. Sine of 60, cosine 45. This, using what we found, this is square root of 3 over 2. This is square root of 2 over 2. And then we can just multiply these things together to get these other expressions. All right, and then calculators for these non-special angles. If it's not 30, if it's not 60, not 45, pi over 3, pi over 6, pi over 4. If we see these angles that we don't recognize, then you're most likely going to be told to approximate and round these things. All right, there's all this stuff that they're showing online. I want you to see, let me go back to this original page, what I would have to do in a TI calculator. So first of all, there are degrees, the first 2. So I'm going to press mode and change from radian to degree, and then second mode to quit. All right, now I'm just going to type in cosine 53, hit enter. All right, there's my number. All right, the next one's cosecant. There isn't a cosecant button, so I have to do the reciprocal. All right, cosecant is the reciprocal of sine, so that's 1 divided by sine, right, of 68 degrees. So 68, and then enter. So there's what I get for that cosecant of 68. All right, now tangent. Now this is back, there's a pi, so this is back to radian mode. So I'm going to click mode, down to radian, second mode to quit. All right, tangent is on the faceplate, so I can do 5 pi is second caret divided by 12. All right, and you can see that I'm getting the same thing that they're getting on these calculator images that they're showing you. All right, then you look through these. There's several different examples of applications on here. Just kind of read through them. I'll just kind of show you this one. So we're on one side of a river. We can see another point of reference on the other side of the river. I can walk from here to a point that's directly across, like a straight line across, and I can find the angle from that point of reference on each side of the river that have that 90-degree angle across from them, and now figure out based on that distance and that angle what this length needs to be. And the way that I'm going to do it is decide what this length is relative to the angle. And again, meaning adjacent, opposite, hypotenuse. So the side I'm looking for is opposite, and I know the angle and I know the adjacent. So that means I'm going to use the tangent trig function to set up the right triangle property here, the ratio. So tangent is opposite over adjacent, b over a is 300 meters. Do a little algebra, multiply the 300 over b is 300 times the tangent, and there's what I get, okay? And you're going to make sure you're in degree mode here, because that is 30 degrees. So you can go down to degree mode, enter 300 times the tangent of 30. There's my number, 173.2. The other thing you could do here is stay in radian mode always. All right, and then if I type that in again, when I get the 30 in there, I can go to second apps for the angle like we saw before, and then put in a degree symbol. All right, so I'm in radian mode, but I use the degree symbol in the angle menu, and now that will override it, that it's in radian mode, and do it as if it were in degree mode. And that way I can always stay in the radian mode. That's an option for you. So if you see the degree symbol, just know you can do second angle and just add the degree symbol, and it overrides radian mode. All right, so again, lots of different applications on here. Just make sure that you are understanding these. If you're having any issues with these, shoot me an email. I'll be happy to go over with them individually in some more detail.